Welcome back to my channel. We are asked to solve A to equal all these, and also to know that we are actually asked to solve A inverse because we are given A to equal all these. So we are asked to solve A inverse. So, and the hint has been given that A inverse equal 1 over A. And also we are asked to show that A inverse equal square root of 3 raised to the power 9 divided by 4. Let's quickly jump into that. Solution. Yeah, before I run into this, I just want you to know that this is a kind of question from GRE that they just want to test your knowledge. Maybe you know exactly what you're doing. They don't really want to stress you. They just want to test your knowledge. In that way, I figure out that this will always be the same answer. They will be the same if you are able to solve them out. We're going to look into them, solve them out, and see how they look like. But my guessing is that they are going to be the same thing. So we're going to look into that, and but without wasting time, square root of 9 raised to the power 1.5 should be the same thing as the square root of 3 raised to the power 2. Reason: if you do this very well, or you do one of them very well, if I try to open this one well, this will be 3 raised to the power 2 into bracket 3 raised to the power 2. I'm bracketing all of them together because I know that the square root is the same thing as saying 1 over 2, right? So in that way, if I cut this out, I cut this out, this cancels this, so I'll still have 3 raised to the power 3 over 2. And 3 raised to the power 3 over 2 is the same thing as 3 raised to the power. Let's look at this one. This one also is going to give us this 9 raised to the power 3 over 2. So if this cancels out, so I'll still remain as 3 raised to the power 3 over 2, which is the same thing as this. How? This is going to give 3 over 2. This is everything in here. So everything multiplied by 1 over 2. Anyways, we continue with that. So this one also is the same thing as 9 raised to the power 3 over 4, which if I solve that, I'm going to have this one to be 3 raised to the power 2 into 3 over 4. So if I cancel 2 here, I am left with 3 over 2. 3 over 2, like this one. So the next one is 3 over 2. So that means that I will be having 3 over 2. Oh, I see. This 3 should be 3 raised to the power 2. I should have, if I multiply 2 here, it would have been better, but it's going to violate the rule. So this should have been 3 raised to the power 2. If I bracket everything together, 3 raised to the power 2 into bracket 3 over 2, and I put everything together this way, that means I'll be having 3 raised to the power 2 into bracket 3 over 2 times 1 over 2. So that means that this can cancel this. If this cancels this, that means I'll be having 3 raised to the power 2. That means that all of them, they'll be having 3 raised to the power 2. And if we solve 3 raised to the power 2, this is going to give us 3 raised to the power 3 the square root of 3 raised to the power 3. And in that way, the square root of 3 raised to the power 3 is going to give us 3 root 3. That's going to give us 3 root 3. And if I say 27, this is going to be 27, square root of 27. I'm coming back here. Square root of 27 is same thing as the square root of 9 times 3, which is same thing as 3 root 3. So that means that this, we give 3 root 3. If we know that all of them will give 3 root 3, so it will be easier for us to now say A will now equal to 3 root 3 plus 3 root 3 plus 3 root 3 plus 3 root 3 divided by 3 root 3 multiplied by 3 root 3 times 3 root 3 times 3 root 3. Fine. So if that is solved, so I can factorize this and say 3 root 3 into how many places? 1, 2, 3, 4 into 4 places divided by, so this is going to give us, the denominator is going to give us 3 times 3 times 3 times 3, 1, 2, 3, 4, times root 3 times root 3 times root 3 times root 3. So that is what we're going to have. So in that way, we can continue and say that 3 root 3 is the same thing that will give us, 12 root 3. 12 root 3. 12 root 3. 12 root 3 divided by 3 times 3 times 3 times 3 will give us 81. Because 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is going to give 81. Then we have all this into the same square. 3 times 3 times 3 times 3. That's the law of surd. That's how you can put them together, provided they have the same multiplication. So that it will be easier for us. So 3 times 3 is going to give us 9. The square root of 9, I'll solve that. So we have 12 root 3 divided by 81 times, this will be square root of 9 times 9. And this is going to give us 12 root 3 divided by 81 times 9. Because the square root of 9 times 9 is just like the square root of 9 squared. And we're going to have that one as 9. So we can split this, because we can say this one also can give us 4 times 3 root 3 divided by 81 times 3 times 3. So in that way, 3 cancel here, 3 cancel in there. So we should be having 4 root 3 divided by 243. So that means that A equal 4 root 3 divided by 243. In that sense, 1 over A, or A inverse, is going to give us 243 divided by 4 root 3. In which you may want to leave your answer in this way, but we all know that we don't really want to leave our denominator in square root. So in that way, we can solve that further. If we solve that further, we're going to have, what you have to do into that is to find a way to eliminate that square root. And what do? You multiply both sides. We multiply both the top and the bottom, which is the numerator and the denominator, by the same square root. So square root of 3, square root of 3. It's just like nothing has been done to it. So this one we give 243 root 3 divided by 4 times 3. Because root 3 times root 3 will give us 3. So 4 times 3. So now we can say 3 here 1, 3 here 8, and 3 here 1. So that means we have 81 root 3 divided by 4. 1 over A is 81 root 3 divided by 4. But we are also asked to show that is the question 2, that we should show that A inverse equal square root of 3 raised to the power 9 divided by 4. So what do we do in there? What we're going to do now is that A inverse now is going to give us, let's try and split this if you translate this 81 is the same thing as 3 raised to the power 4. And the square root of 3 is the same thing as 3 raised to the power 1 over 2 divided by 4. So if you look at that, and if you look at the law of indices, the multiplication law of indices that said a raised to the power m times a raised to the power n is going to give a raised to the power m plus n. So the same thing, because they have the same base, we're going to do the same thing, that 3 raised to the power 4 plus 1 over 2 divided by 4. So our A inverse is that. So I'm just trying to squeeze it in here. I'm going to try to squeeze it in there, that A inverse equal to 3 raised to the power 4 plus 1 over 2. 3 raised to the power 4 plus 1 over 2 divided by 4. And if we find the LCM, I have 3 raised to the power 2 times 4, 8, plus 1, 9 over 2 divided by 4. So our A inverse is the same thing as, if we go back to the law of indices, it's going to give us the square root of 3 raised to the power 9 over 4. So that has been proven. But let me quickly say something. That is a proof that we won. That is how you show that A inverse equals to this. But I will quickly want to say something about this 3 9 over 2. 3 raised to the power 9 over 2. How do we come into that? Is that if you look at the law of indices that says A raised to the power m over n will be the same thing as A raised to the power m into the square root of n. A raised to the power m into the square root of m. So the same thing applies in here. So 3 raised to the power 9 over 2 is the same thing as the square. It's going to give us the square of, it's going to give us the square of 3 raised to the power 9. And that's how we got the square root of, it's going to give us the square root of 3 raised to the power 9. So it's the same rule that was applied in there. So that is it. Thank you very much for watching the video and for listening to the video. I will see you in the next one. Thank you.